Here we go, Unit 7. This is going to be a unit where we're going to be making some comparisons, and hopefully you've learned about the way we rate comparisons in math, which is generally called a ratio. You know, like if you're going to compare the score of a basketball game and it's 48 to 53, that's a ratio. Or mullet ratio. Yeah, trying to bring back some 80s here. Mullet was a business in the front, party in the back. So if you want to compare the business to the length of the party here, you got a ratio. Let's get down to some nitty-gritty. So a ratio is something that uses division to compare two quantities. And so, for example, if we're going to compare A to B, we can write that in one of three ways. You could write it like using a colon between them. A is to B, or the ratio of A to B. You could use just the word A to B, like when you're telling the score of a game, 48 to 53. It's a ratio. Or you can write them as a fraction, A compared to B, or A to B. And that's the way we're going to generally be writing our ratios. And then remember that we want to write these ratios in lowest terms. So if you can reduce it, you want to. Here's an example. There are 12 boys and 5 girls in the Lumberjack Club. Yep, that's a real club. That's a club where they go to school early, wear plaid, eat pancakes. Totally awesome. So we're going to write the ratio of boys to girls. And when you write a ratio, I want you to write down the way you're making the comparison. If we want boys to girls, then we're going to make a comparison putting boys in the numerator, girls in the denominator as our fraction. So this is going to equal how many boys? 12. How many girls? 5. That'd be 12 to 5, or 12/5 is the ratio. Now, you can't reduce that one, so you're done. How easy is that? There's the ratio. Now, write the ratio of girls compared to total club members. So we're going to go girls, and we're going to compare that in a ratio to the total. So one more time, how many girls are there? There's 5 girls in the club. Total club members. Now we're going to have to do some adding. So how many total in the club? 12 boys and 5 girls. We got 17 total. So it's 5 to 17, and that's my ratio. And you're done. All right, now what we really want to know is how to use a proportion. And a proportion is simply an equation that states that two ratios are equal. So we're going to write equations. It might be A is to B as C is to D. You would write that this way. A is to B, there's one ratio, A is to B, as C is to D. C is to D, and then you're going to just state that they are equal. A is to B as C is to D is a proportion. Those are equal ratios. Now, you're going to need to know how to solve one, and this is where our real work is going to start here. Not so easy as the first stuff. When you're solving a proportion, you're looking for the value of x. Generally, you would have something you don't know. And the way you do that is you use cross products. So cross products is just what it says. You're going to cross, and you're going to multiply. In fact, sometimes we call it cross multiply to solve that. So here's how it works. One of the properties of a proportion is that you can multiply across. In other words, you can take the numerator multiplied by the denominator of the other one, so 3x times by 3, and it will equal the product of the other pair of numbers, so 27 times by 2. And we don't generally write all this stuff out, we just do the math. So it's 3x times 3, that's 9x, and 27 times 2 is 54. And then one last step in the algebra to divide that 9 out, and you get x is equal to 6. And that would be the solution to that proportion. And they can get a little more complicated, like you see here in this example. There's quite a mess up here, but let's see how cross products are used to solve this. So one step you might do is start by taking 7 times x, setting that equal to the cross product over here, 3 times 2x plus 5. Now be careful on this one. Pause the video here if you need to, but you need to write that this way. It's 3 times 2x plus 5. Notice how I put that in parentheses. That's because I need to make sure the 3 gets multiplied by all that stuff up there. So, moving on, we do have some simplifying that we need to do here on this side. Let me draw that line I like. So I'm going to multiply that 3, just distribute it into the parentheses. So we get 6x, and 3 times 5 would give me plus 15. And bringing down our 7x. Now let's solve for x. Just take away the 6x from the right side there. That brings me down to just 1x equal to 15. So that's our solution. Okay, so cross products are kind of helpful. They get rid of those fractions that we find in ratios so often, which I love. All right, let's see how this one goes. Looks like quite a mess here. One thing I would notice is this is a negative number right there, and a lot of kids will get confused about what that negative means. So I'm going to have you rewrite that. Let me just copy down this first part. Okay, so we're on this negative. Now the negative needs to apply to either the numerator or the denominator. And I'm going to say that again. It's one or the other. I think it's probably easiest just to put it up in the numerator with the 2. So let's look at that as a negative 2 and then bring down the w minus 10. So the thing is people think they have to put the negative on both. That's not the case. You put it on one or the other to keep the whole thing negative. Okay, cross multiply to solve this. So here's my first product, 6 times w minus 10. Notice those parentheses again. And then it equals 4 times that negative, or no, 4 plus 2w times that negative 2. So I'll put the negative 2 in front and put the parentheses around the part that has more than one term, the 4 plus 2w. Okay, I'm getting bored with the blue. We're going to change colors here. Let's distribute and start to solve this. So we got 6w and then minus 60. Over on this side, we got a negative 8, and negative 2 times positive 2w is negative, oh, wrong. Negative 2 times positive 2w would be negative 4w. Okay, let's get w's over on this side. So I like them there. Let's add the 60 over, and let's add 4w so that it can move over to this side. All right, what are we looking at? How many w's there? We got 10w. My negative 60 cancels my positive 60. Combining on this side, I've got a negative 8 plus 60, so I'm thinking 52 there. And then these, of course, wipe each other out. Let's divide by 10 and find our value for w. And I really like that this has come out as a decimal because you guys seem to panic when you get decimals. Life is about decimals. It's not always nice numbers for you, so don't panic when you get those. Okay, let's check the steps out again. So we cross multiply, then we get to just isolate our value and we're done. Those cross multiply steps are nice. All right, this last example, we're going to do a real life deal with how proportions work when reading a map. We want to use the ruler here to estimate the distance from Cleveland to Cincinnati. So as I look at this, I need to notice down here is a scale, which is going to help me with my proportion. Now, the scale is usually written, and this is a general rule, you put your scale measure compared to the actual measure. So when you see 1 centimeter to 60 kilometers, your actual distance is 60 kilometers for every 1 centimeter you measure it out. So if I want to know the distance from Cincinnati to Cleveland, I'm going to have to grab this ruler and I'm going to have to measure that on my map. All right, lining that up, we've got, it looks like it's about 3, yeah, check this out on your own notes, about 3.5 centimeters. That's on my map. So 3.5 centimeters, let me just jot a note of that. Okay, so how can I use a ratio or a proportion to figure out the distance, actual distance from Cincinnati to Cleveland? Well, if I'm going to set it up, I'm going to go with the scale measure or the map, and I'm going to compare that to the actual measure. So on my scale, I've got 1 centimeter, and the actual distance compared for 1 centimeter is 60 kilometers. That comes right here from the key. Now I want to set that equal to what I measured. What did I measure on the map here? I measured 3.5 centimeters, which I want to compare to, we'll call it x. This is our question. How many kilometers is that equivalent to? Now the units, they're all matching up. They're all good. So we really just need to look at these numbers and see how they work out as we solve the proportion. Let's cross multiply 1 centimeter by x kilometers, or 1 times x is just going to be x. And on this direction, cross multiplying is 60 times 3.5. 60, so let's see, 60 times 3 is going to be 180, and 60 times a half is 30. So 180 plus 30 more would be 210. So cross multiplying that gives me 210 kilometers. And that is the distance right about that, from Cleveland to Cincinnati, give or take a mile or a kilometer or two. All right, so that's proportions and ratios, and we're going to use these through this whole unit. We're going to use them a ton. So I wanted to do this as a little reminder review of how to solve a proportion for the most part, and then we will rock and roll with these as we move on to the geometry steps. See you in class.